So in the finding the number of permutation in factorial, that means I have, like I come to your class, I have 10 girls. So the first, when I come, I see 10. Now I choose Lemma as an example. So after I choose Lemma, I have 9 girls now. Then I take Lana. I have now 8 girls. After that, I take Maya. I have 7. Rose, and so on, until I choose all of you. So if I want now to make arrangement of you in particular order, that's mean I take 10, or I have 10, sorry, first. Then I take 1, I have 9. And I take 2, I have 8, and so on. To represent this number of permutation, I will use something we called it factorial. So this number, since I start with 10 and I'm counting back, I write it as 10 factorial. 10 factorial, that means I have to choose 10 girls in particular order. Here you have 12 folders. You want to file these 12 folders. You want to arrange them one by one. The first time you will have 12 folders. When you take one of them, you have 11 folders. After you take another one, you have 10. And then you have 9, 8, 7, 6, 5, 4, 3, 2, 1, and I will stop here. Or I can write it as 12 factorial. Without multiplying all of these numbers on calculator, you will have this factorial number, which is in, where is it here? Oh, do you see, it's clear here. It is under mode in your calculator. You can write make 5 shift, shift, and this sign, which is under mode in your calculator, you will see like X factorial in your calculator, that you can write 12 factorial and you will get the answer. Without multiplying 12 times 11 times 10 times 9, you will find that you have 479 millions, or approximately 479 millions way to order this box. Is it clear? Here I have 12 folders. I want to arrange them in particular order. That means I have the 12 first time. After I take the 12, I have 11. After I take another book, I have 10 choices now. And I will continue until there's no book in my folders here. Is it clear? Why we use the n factorial?
Yes, teacher.
N factorial. I want to arrange all the given books in order. I will use the n factorial. Here we have another example. You have 8 shirts. You want to arrange them on hangers on a closet. So here you have 8 shirts. So the first time, how many shirts you have? You have 8 shirts with you.
8.
After you take the first shirt, how many shirts are
7.
now? 7.
7.
After that?
6.
6. Then
5.
5, 4, 3, 2, and 1. Or instead of writing these things, I will write it as 8 factorial. This number factorial. On calculator, write 8 shift. I'm sorry, it's clear from my maybe E of X, or it's clear from my calculator. And the answer will be 40,300 20 ways to arrange these 8 shirts on hangers.
Teacher,
Yes, Rose.
like, what do you mean about this? We have 40,320 ways to arrange it. Like, we can make it 765 or 432. Like, what do you mean about it?
Like here you have red, blue, pink, yellow, green, and so on. 8 different colors of your shirt. So the first time you can arrange green, then blue, then yellow, then blah 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 until you
Or
finish
like
them.
arrange the numbers, like maybe 765 or maybe 321, like that.
Sorry, can you repeat?
Like you mean like if we say 432 or 765, like arrange that, like just arrange the numbers in a different way.
Arrange the shirts in different way. Yes, that's mean you can choose the first time you can choose green, then you choose yellow, then you choose pink, then you choose and so on.
Oh, okay. Thank you, teacher.
So, but not every time. If you come, let's come back to your closet. You not rearrange them. You cannot choose the same color. You can choose another colors. You can start with yellow, or then red, then green. That's me. Here we have 40,000 ways to arrange your shirts.
Yes, teacher. Thank you.
Yeah. So here, by now, you have to know that 8 factorial or 5 factorial, it's mean you have to multiply 5, then you have to go back with the numbers 5, 4, 3, 2, 1. You multiply them. 6 factorial, it's mean 6 times 5 times 4 times 3 times 2 times 1. Also, you can write 6 factorial as 6 times 5 factorial. Is it right? Look here. They are the same. Just substitute 5 times 4 times 3 times 2 times 1 with 5 factorial. So you can write 6 factorial as 6 times 5 factorial. Why I use it? Sometimes if I'm asking you here to simplify like this, how can I simplify? I can write 10 factorial as 10 times 9 times 8 factorial over 8 factorial, and then after simplifying, I get the answer is 90. If you try it in calculator, like 10 times 9 times 8, 7, 6, 5, 4, 3, 2, 1, and 8 factorial, 8, 7, 6, 5, 4, 3, 2, and 1. If you simplify them, 2 cancel 2, 3 cancel 3, 4 cancel 4, 5 cancel 5, 6 cancel 6, 7 cancel 7, 8 cancel 8, you will see that you have only 10 times 9. Is it clear?
Yes.
Yes.
So I can rewrite 7 factorial as 7 times 6 factorial, or 7 times 6 times 5 factorial, or 7 times 6 times 5 times 4 factorial. All of them are correct. Is it clear?
Yes.
Yeah. Yes, teacher. Yeah.
Let's evaluate these expressions here. Number 18 in your book. 10 factorial over 7 factorial times 3 factorial. How can we simplify it here? Since I have 7 factorial down, keep it as it is. and I want to write 10 factorial, but I will stop at 7. Like I have to say it is 10 times 9 times 8 times 7. And since in the denominator I have 7 factorial, I have to stop here to simplify them. Then I have to multiply or to find the factorial of 3. What is the factorial of 3? It's 3 times 2 times 1. Is it right?
Yes, teacher.
Then 7 factorial, cancel 7 factorial. Then you can simplify now. So the answer is 3 times 4, 12 times 10, 120. So the answer here is 120. Is it clear?
Yeah.
Yes.
Okay. Let's choose now number 19. 15 factorial over.
You'll stop at 10 factorial.
10 and 5. Yes. Here I have 10 factorial down. So I will stop at
10 factorial.
10 factorial. Exactly. 15 times 14 times 13 times 12 times 11 times 10 factorial. And then I will write the factorial of 5, which is 5, 4, 3, 2, and 1. Then they cancel each other. Then we can simplify.
It's 3003.
Yeah. So 3 times 7, 21. 21 times 13 times 11. What is the answer, Habiba?
3003.
3003. Is it clear?
Yes, teacher.
Yes.
Okay.
Yeah.
Now, sometimes you are interested in the number of permutation possible using all of these objects from the set. Like I told you, you have 12 folders. You want to arrange the 12 or the whole 12 folders. So if you want now to arrange the whole 12 folders, you will use you will write it as a 12. You write as a 12 factorial. So if you want to arrange the whole 12 folders, you will use the factorial. You will say it's 12 factorial. But sometimes you didn't want to arrange all of them. You'd want to just take a few of them now. If you want to take a few of them, like you want to arrange 3 of 12 blocks or 12 folders, you will use permutation way. This one, it's mean a permutation. I want to count of the range of 12 blocks, and I want to take 3 of them. This mean here that I want to arrange 3 blocks from 12. So if you want to arrange the whole 12 folders, you will use the factorial. You will say 12 factorial because you want to arrange the whole numbers. Like I want to come to your class, so I have to choose to take all of you in order, 10 girls. So I have 3 millions. approximately 3 million ways to arrange you. But if I want to take 3 girls from you in order, I have only 720 ways. So this one, it's mean the number of permutation that is 12 that is arranged in 3. Oh, that I want to arrange 3 from 12 girls. So sometimes you are interested in the number using all of these objects, but sometimes you don't want to arrange all of these folders. You want to arrange few of them. You can use the permutation way, or you can use the fundamental counting principle. What does it mean? That means I can say it is 12 times 11 times 10, and I will stop. That means I want to multiply them, and I will stop. Is it clear? So arrange the whole number, the whole of the 12 folders. I will use the factorial. If I want to arrange a certain number of 12 folders, I will use the permutation. Let's have an example here. Oh, sorry, before that. The number of permutations of a set arranged R is, this is, as I told you, the number of permutations of 12 that is arranged, that is a set arranged of 3 is. So this is n and this is r. Is n factorial over n minus r factorial. Like if you have here, you will say it is 12 factorial over 12 minus 3 is 9. So you have 12 factorial over 9 factorial. Another example. If you have permutations of 4 arranged from 10, you will say it is 10 factorial over 10 minus 4 is 6. So it is 10 factorial over 6 factorial. This is how to find the number of permutations. This is our formula. N factorial over n minus r factorial. Let's have this example here now. 10 students are in a race. First, second, and third places. If you see these words, first, second, and third, that means I'm talking about arrangement. That means I want to arrange them in order. Okay, so first, second, and third, that means we have here an order. Since we have an order, so I have to use the permutation. In how many ways can 10 runners finish first, second, and third? So like I come to your class, I want to choose the first and the second and the third one. So I want to choose 3 girls in order. I said it is, I have 10 girls. I want to choose 3 from them. What I have to do, I say it is 10 factorial over 10 minus 3 factorial. So it is 10 factorial over 7 factorial, which is 10 times 9 times 8 times 7 factorial over 7 factorial. And the answer is 10 times 9 times 8. This is using the permutation formula. The other method, which using the fundamental counting principle. What does it mean? Like, I will use the factorial, but I must stop at a certain number. I didn't want to continue until number 1. I have to finish, to stop at a certain number. I told you I have 10 girls. So I have first, second, and third. So 10, 9, and 8. The first, I want to choose the first girl, I have 10 choices. When I have to choose the second girl, I have 9 choices now. And when I want to choose the third girl, I have 8 choices. So you can write the answer in the fundamental counting principle, but I must stop after 3 times because they told me I want them as first, second, and third. If I want them as first, second, third, and fourth, I have to say 10, 9, 8, 7. Or using the permutation formula.
Teachers, it's clear.
Yeah.
Okay, let's have another example now here. 15 students asked to visit a college admissions counselor. Each scheduled visit includes 1 student. So they are scheduled, they are ordered, they have an arrangement. So that's mean what? I have to use the permutation. In how many ways can 10 time slots be assigned? So, as I told you, since I told me that I have a scheduled visit, so I'm talking about permutation. How many students we have in all?
15.
15.
15.
How many they want to go?
10.
10.
10. What we have to write up here?
15.
15, exactly, over
Factorial and over
15
minus
minus 10.
10.
Factorial.
Exactly. Which is 15 factorial over 5 factorial. If you try them here on calculator, 15 factorial is a big number. 5 factorial. So the answer will be 1.089 times 10 to the power 10 ways. Yes, clear?
Yes.
Yes, teacher.
Yes.
Shall we continue now? Talk about combination?
Yeah.
Okay, we have a lot of time. Yeah. Okay, now. So in this lesson here, we didn't start the probability. I'm just talking about the ways of counting. So this lesson, permutation and combination, I'm talking about ways of counting. We learned 3 ones by them. I can say, sorry, 2. We can have a permutation and we have a combination. Permutation, I have 2 things. If I want to take the whole number, I have to use unfactorial. If I want to take a arrange set of numbers, I mean, like 3 from 10, I will use the permutation. But if I have now to take 10 or 3 girls from 10, but without order, I will use letter C, which is combination. P, permutation. C, combination. 3 from 10. But for the first case here, that I want to choose 3 arranged number of girls or 3 arranged girls from 10. But for the second one here, I want to take any 3 girls from 10 without order. So the order is not important. So, like imagine now you have a championship race. For the championship race, you must know who is the first, you must know who is the second, you must know who is the third. You must know how many ways you will find the first, the second, and the third. So we'll use the permutation. But in the combination, like you put your hand, the first 3 girls touch your hand without order. Okay, any 3 girls touch your hand without order, you will use the combination. Because without order, you didn't see, no, Lana is the first or Maya is the second. Any 3 girls, any first 3 girls touch my hand, so I will use the combination. But if I want, say no, stop, Rose is the first, Haneen is the second, Ragad is the third, I will use the permutation. So permutation order is important, combination order is not important. So in this case, the order in which the first 3 runners cross the finish line does not matter. So when you want to select and the order does not matter, we will use a combination. And since we have a formula for the permutation, we have a formula for the combination. What is the formula? I write it as C, as I told you. I write as a number of combinations of 12 that I want to choose 3 from them. What I have to do? I will write n factorial over n minus r factorial, like this is for the permutation. Then I multiply them for r factorial, which will be now combination. So n factorial over n minus r factorial is a permutation. But n factorial over r factorial times n minus r factorial will be a combination. So I can write it as, that's mean I can write sorry. I can write 3 girls taken from 5 as I can write it like this. Is it right? I told you that n over n minus r factorial is p factorial, is p, sorry, over r factorial. But this is not very important, just an extra information here. Just I want you to know that the permutation is n factorial over n minus r. But the combination is n factorial over n minus r factorial times r factorial. So let's find 3 from 5 now. The number of combinations of 3 taken 3, 5 take 3. I will say 5 factorial over 5 minus 3 factorial, which is 2, times this number factorial. So it is 5 times 4 times 3 times 2 factorial over 2 factorial times 3 times 2 times 1. You will find that the answer is 10. So which is a greater, permutation or combination? That's mean permutation of 3 from 5 or combination of 3 from 5?
Permutation.
Permutation. Because the combination is a permutation over 3 factorial. So the permutation over 3 factorial give me a combination. So the permutation of the number of ways in arranged order is greater than the number of ways without arrange. Let's have now this example here. What is a number of combinations of 13 girls as an example taken from 4? What is the formula of the combination? I will write it here.
13 factorial over 13 minus 4 factorial multiplied by 4 factorial.
Yeah, it is n factorial over n minus r factorial over r factorial. So as Susan said, we have to write them up here. 13 factorial over 13 factorial, 13, sorry, minus 4 factorial, all times 4 factorial. Is it clear?
Yes.
Yes, teacher.
Okay, I will do this cut it here now, and tomorrow we will continue. I think we finished, but we have to solve more example, and we have to identify whether the permutation or computation from the word problem. Here now, what is the value of each expression? Look at A. We have the number of computations is 8 taken 3. Yes, Habiba, what you have to do?
So n factorial, which is 8 factorial over r factorial, which is 3 factorial.
Exactly.
8 minus 3 factorial.
Thank you so much. This is for A. For B, Maya.
Yes.
It's Maya. Here now.
9 factorial over 9 minus 2
Times what? This is
times
permutation. I want the combination. Times 2 factorial. Okay, Maya?
yeah.
Okay. Now let's choose Sarah. Are you here? Ah, yes, Sarah is here. Yes, Sarah.
Yes, teacher.
Sorry. See now. The number of computation, 15 taken 5.
15 over 15 minus 5.
Exactly. Times
10.
times 5 factorial.
Teacher, you should simplify it, right? Or just leave it like that?
Yeah, you can simplify it by or find it by calculator.
Okay.
That's it. I will stop here today. Do you have any question?
No, teacher, thank you.